Order. 3. All right, so my last video got cut off. We ran out of time, so I want to start back up with number 26. And our answer here is x is greater than 20. Sorry, I just have to change my pen. And you can see below my inequality the graph and the representation in interval notation starts at 20 going towards positive infinity because that makes us see that our numbers are getting bigger and bigger and bigger. All right, that brings me to number 27, and I think this is a great example because you end up having to flip twice here actually. So what we want to do is you want to get everybody away from the x, so we're going to subtract 8 on both sides of that inequality symbol. 36 minus 8 gives us 28 is greater than negative 2x. And so watch what happens here. You got to be really alert and aware. We're dividing by a negative number. When the number you're dividing by or multiplying by is negative, you flip the symbol. Then look what happened here. X ended up on the right. And unless it's an and inequality written as a single inequality, this year we always want x to be on the left. And so to rewrite it so that x is on the left, we flip everything. X is greater than negative 14. And here's the graph of that inequality and its representation in interval notation. Okay, so let's move on to compound inequalities. We'll do one example of each. We've done a lot of examples this week. Number 28 is an and inequality written as one single inequality. So we actually didn't see any like this in class where we had to distribute first, but that's not a big deal. I'm showing you right now. Just like before, we're working from the middle and we're distributing 2. So you get 0 is less than or equal to 2x plus 12. Is less than or equal to 20. Okay, so now this looks a little more like what we're used to. We're going to work from the inside, the middle, and we actually have 2 inequalities here. We have the first one, which is 0 is less than or equal to 2x plus 12. And then we have this second one, which is 2x plus 12 is less than or equal to 20. Now, you can separate them as 2 separate inequalities to solve, or you could do it in one inequality and just make sure that whatever you do to get your x by itself, you do to the expression with x, and you do to the left of the first inequality symbol, and you do to the right of the second inequality symbol. So that leaves me with negative 12 is less than or equal to 2x is less than or equal to 8. And now I need to get x by itself by dividing by 2. But again, whatever I do to the middle, I need to do to the left and to the right of the 2 inequality symbols. And then that leaves our answer exactly the way we want it. We want to write our and examples as single inequalities. Negative 6 is less than or equal to x is less than or equal to 7. And our interval notation is represented right there. All right, please don't stress about OR problems. They look big, they look difficult, but it's really just 2 separate problems. 2 inequalities separated by the word OR that we just write their inequality answers together and graph them together on a number line. No big deal. So we'll start over here on the left. Distribute your 3. We get 3x minus 6 is less than x plus 4. Then we're going to subtract our x on both sides. So we get 2x minus 6 is less than 4. Continue to solve, add 6 on both sides. 2x is less than 10. I'm going to move this up a little bit so it doesn't get in the way of my answer that I've previously written down here. Could just get rid of that. And so you can see we divide by 2 here. And we get x is less than 5. Now I want to go and solve the other half of this compound inequality, and I'm going to subtract my 5x on both sides. That leaves me with x minus 1 is greater than or equal to 6. And then we add our 1 on both sides. And so we get x is greater than or equal to 7, which I have represented right here. So then you just write your answers together with the word or. This worked out nice because the lower number was first and the greater number was second, but we want to make sure we put it in the order with the lesser number inequality first and the greater number inequality second. X is less than 5 is graphed like this. X is greater than or equal to 7 is graphed like this. And in interval notation, X is less than 5 or 7 to infinity. X is greater than or equal to 7. Just want to change something right here. Usually when we have it in interval notation, we use our symbol for or, which is that U. All right, so let's concentrate on some word problems now. 2 word problem examples to look at. So I've already highlighted our important information here in number 30. 3 times a number increased by 7 is at most 19. What I had suggested to you in class was when you see the words at most or at least, you circle them and remind yourself of what inequality symbol that's going to use. At most means the most that could be is 19. So it's going to be less than or equal to 19. Okay, so now 3 times a number. That would be represented with 3n. Increased by 7 is represented with plus 7. At most is represented with less than or equal to, and 19 is represented with the number 19. Okay, so in class we just translated these, but we actually are going to solve this because I want to be able to answer what the largest integer that the number can be would be. So I'm going to quickly solve this. It's nice and easy. You would subtract 7 on both sides. You get 3n is less than 12. When you divide by 3, less than or equal to 12, you get n is less than or equal to 4. So that's part of your answer. But also, what is the largest possible integer? The largest possible integer that is less than or equal to 4 is 4. All right, great. One more problem. A CD holds 90 minutes of music. You have already burned 23 minutes. Songs are 3 minutes long. Write an inequality to solve and state the largest number of songs that you can add to the CD. So I started with the let statement. Let x equal the number of songs that can be added. And I'm actually going to start with the inequality. If a CD can hold 90 minutes of music, it can actually hold less than or equal to 90 minutes. The most number of minutes on it could be 90. We already have 23 minutes taken up. So 23 minutes plus 3 minutes for the minutes for each song times x, the number of each song, has to be less than or equal to 90. This represents what's already used up on the CD, and this represents 3 minutes for each song that we might add to the CD. Now we go to solve, subtract your 23 on both sides, and that gives us 3x is less than or equal to 67. And then when we divide by 3, we get x is less than or equal to 26. I'm doing this in my head. 0.3 repeating. So how many songs could we add? Could we add 27 songs? No. Could we add 26.3 repeating songs? No. We want a whole number of songs. So the largest number of songs that we will need